Hi, and welcome to the second in our series on how to trust your player. I'm Alan Ogilvie, Lead Product Manager at Friend MTS. I'm with Ali and Nicola.
Hello, this is Ali Hajjat, Product Marketing Director at Intertrust.
Hello, I'm Nicola Wadi. I'm a Senior Solutions Architect at Intertrust.
Thanks. And if you've been following our partner series so far with Bitmovin, Intertrust, and Friend MTS, we've been taking you through the components of any streaming media solution looking to protect their investment and revenue. In the second article we've just published, Ali and Nicola discuss in more detail on the best practices with any solution leveraging multi-DRM such as Intertrust Express Play. So, Ali, what can we expect in our chat today and what are the topics?
Sure. Yeah. So obviously, I think it's important to know that hackers have technical skills and they develop new ways to attack streaming services. And they technically use and leverage the same technologies and tools that legitimate OTT services actually do use. So today we want to kind of go over the best practices that this DRM technologies should be implemented by the OTT service providers, and kind of trying to help and prevent attacks to the multi-DRM platform that try to extract content keys or extract DRM licenses, or even attacks that try to bypass license checking rules. So for example, we will be talking about securing interfaces between the multi-DRM platform and encoder and packagers. We will talk about how to protect the DRM license acquisition workflows from hackers, and also how to enforce only authorized devices and platforms can access the DRM licenses and decrypt the content. There has been a lot of details in the article we published last week, so we're going to touch base at high level some of the important points, and we encourage everyone to go back and read the article.
Can you take us through some of those initial steps to protect content with DRM?
Definitely. So, obviously any video streaming workflow starts with content preparation and content packaging. And so one of the critical steps of content packaging is actually embedding DRM signaling and encrypting the content using the keys that are provided by the multi-DRM platform, multi-DRM service. So it's really important for the content packaging workflow and the multi-DRM service to be tightly integrated and use a secure interface for exchanging signaling and keys. And so basically, one of the important protocols that have been used recently is so-called SPEAK, which is actually Secure Packager and Encoder Key Exchange Interface. And it was initially introduced by AWS, and further on was used and adopted by different vendors like Bitmovin. So as you can see on the screen, basically, if there is a tight integration between packager and encoder, in this case, Express Play multi-DRM platform, be it Bitmovin packager, there is a confidence that the interface is secure, and technically all the signaling and encryption keys are provided encrypted and through the secure channel between the two parties. So this is one of the main first best practices that should be considered as the streaming service providers start to build their video workflow.
So the video player receives a valid license to begin decryption and playback, the license acquisition step. What are the common attacks used by pirates and how can we mitigate them?
Good question. So obviously devices and players need to retrieve the DRM license before playing the content. And hackers also try to attack the same DRM license workflow or servers in order to extract the DRM licenses. And so there are typically two main workflow or deployment workflow that are used today. One is called the direct license acquisition model, in which where technically the subscriber's device and players directly connect to the multi-DRM or communicate to the multi-DRM service in order to retrieve the DRM licenses. And the second model, which is the proxy license acquisition model, is the model where the OTT service platform technically delivers DRM license directly to the subscriber. And so there is no additional interface between the devices and the players and the multi-DRM platform. So let me bring in Nicola here to this discussion. I think before we discuss these two models, it's important to understand what are the steps that needs to be taken in preparation for the DRM license acquisition workflow. Nicola, how about you explain how the player technically authenticates before retrieving a DRM license when they want to connect to the OTT service platform?
Well, let's take, for example, the direct license acquisition model. And as we can see in the flow diagram, and actually very similarly as other types of cloud services, this workflow really requires some form of authorization indeed, which is typically implemented by leveraging some secure token. As the diagram shows as well, the token is first acquired in this case before being passed in the DRM license transaction. That's why this approach is also commonly referred to as an upfront token authentication workflow. Now, the secure token itself is encrypted to ensure confidentiality and includes some digital signature to ensure its integrity. With these ready, it enables a robust and secure mechanism to deliver all the settings on all the parameters to the multi-DRM service.
Okay, thanks, Nicola. Ali, can you tell us how the direct license acquisition model works then?
Sure. So there's a lot of details about this model in the article, but if you want to look at it at very high level and simplify it, so it starts by actually requesting an authorization token from the OTT service. So the device needs to first know what parameters has to be passed to the multi-DRM platform, so it needs to request the authorization token. And so as you see on the screen, the OTT service providers basically retrieves this secure token or authorization token, as Nicola was explaining, from the multi-DRM platform. In this case, is the ExpressPlay DRM service, and then delivers it to the subscriber or the player on the device. Now, the subscriber will use this authorization token to request the DRM license. And the multi-DRM platform has the APIs for such a request. And when they receive the request to deliver the license platform, they would actually first validate the secure token, make sure it has the parameters that is assigned by the OTT service providers required for receiving the DRM license. And in that case, they would actually create a DRM license based on the setting and policies that are defined for that specific user, again, by the service operator or OTT service provider, and then delivers this DRM license back to the player, and the player can start to decrypt the content.
So, Nicola, can you give us a bit more detail on the authorization token, as it seems critical for delivering the DRM license to the target device? How can we prevent hackers from reusing that token from unauthorized devices to retrieve that DRM license?
Well, Alan, that's a very good question indeed. There are a few methods to achieve this goal. Methods include, for example, limiting the lifespan of the DRM authorization token to some sufficient short duration. Therefore, the client application really needs to retrieve the DRM license before the token expires. Or another method involves to bind the DRM authorization token to some form of device identifier. Therefore, only the specific authorized device will be able to retrieve the DRM license within the given token.
Okay, so that's direct license acquisition. How does the proxy model work, Ali?
So the proxy model is actually a more advanced workflow that enables the video player to just communicate directly with the OTT streaming service provider. So basically, the OTT streaming service provider is managing a proxy server that retrieves the DRM license from the multi-DRM platform and delivers it directly back to the player, as you can see on this diagram. So there are certain benefits of this approach. For example, the DRM license server APIs are not exposed to the devices and the players, and therefore hackers also don't have access to the multi-DRM service APIs anyway. And also, there are other benefits in the sense that the OTT service provider can bind the DRM license to a particular device or a particular session. They have more control in this workflow. And for example, you can even enforce geo-blocking, right? Only deliver the license if the client is actually in the right location. So there's certain benefits in that sense for the license pricing model.
What are some of the security best practices that are required for the proxy model, Nicola?
Very good question, Alan. As Ali just mentioned, in this model, the license proxy is directly facing all the playback requests from the end clients. So a consequence indeed is that it becomes a potential point of attack. And back to your question and to your point, it has to be very carefully designed and implemented according to security best practices. As an example, such best practices can include to authenticate the request coming to the license proxy endpoint. Again, this could be achieved using some secure token mechanisms, or could be restricting the endpoint load HTTP methods to just and only those necessary. As an example, a DRM license request is usually only performed through a HTTP post method. So in this case, there is no real reason to allow any other method like get or put over HTTP. One other best practice is really to restrict and validate the request content types to only those necessary for the DRM license transactions. And last example, well, I would say validate all the input parameters, and maybe that's the most important one. This includes check the parameters length, range, format, and eventually check the parameters type, if there is any. And obviously reject all the invalid combinations.
Okay, that's the two different license acquisition models and the secure token workflow. What about the level of security employed in the DRM encryption itself? What are the things to think about there?
Let me answer that. So basically, there are, DRM best practices that leverage configurations, policies, and restrictions. And one of those examples is the DRM security level, which is actually a concept that defines the security tier for the target device. And that really depends on the hardware or software features of the device security implementation. So there are technically two main distinct tiers. One is called the software-based DRM client, and that's the model where the DRM client implementation is mainly in software, and it uses a white box cryptography technology like white encryption to protect that application or software. And so the main examples of this type of security model or security level are the Play Ready S security level 2000, SL2000, and the white wine level 3 or so-called L3. Now, the second model is the hardware-based DRM client, which really leverages trusted execution environment, TEE, and also enforces decryption of the content in a so-called secure video path. And so there are certain examples of the hardware-based DRM client as well. One is Play Ready security level 3000 or SL3000. And the white wine level 1 or L1. Now, how do the operators can actually leverage these security levels? So basically, they can map the security level to a certain type of content per resolution or a certain track of the video or audio. For example, if it is related to the standard definition content or audio, it can be technically configured to be played back on devices with software DRM clients. And then there is no other restrictions in the DRM license. So any device with a software DRM client can play back the SD resolution. On the other hand, they can enforce, for example, the HD or 4K or UHD content to be enforced by the license that it's only playable or the keys can be retrieved when the device is actually a hardware-based DRM client. So it's more restrictions on what type of devices can actually play back that content. And these are all, policies that can be enforced through the DRM license.
Sure. So there are different levels of security depending on the needs of the content and the amount of protection required. This obviously relies on our ability to understand the environment for playback and know what levels of security is possible depending on the platform. How can we trust our player? Are there any tips around that, Nicola?
Well, that's definitely a very good point, Alan. So, as an example, in the case of Widevine DRM, or in the case of Widevine ecosystem, there is one essential concept which is called Verified Media Path, or VMP. The overall situation is that modern browsers rely on a W3C standard, which is called Encrypted Media Extensions, or EME, which defines interfaces that the web applications use for provisioning the browser's stack with a DRM license. And one critical component of EME is called the Content Decryption Module, or CDM. The CDM really is the core DRM component and evaluates the rules specified in the DRM license and ensures, in particular, that the content key is handled securely. Now, back to Widevine case, in the situation like Chrome or Firefox browsers, in particular on desktop computers, these browsers don't use a native DRM client. So essentially, the CDM uses software-based DRM client like Ali just mentioned before. And this is where the Widevine VMP plays an important role, ensuring that the browser media processing stack has been validated and has been authorized by Google and by Widevine.
Ali, how much enforcement of VMP is done when using Widevine DRM?
Alan, that's a good question. In the past few years, actually, Google has deprecated all the CDM versions that do not contain VMP functionality. And it's now really mandating VMP for all browsers for Widevine DRM. So, also actually this is important. Recently, Google is strictly enforcing VMP requirement in such a way that Widevine license server only delivers the DRM license for devices that support VMP. So it's really a huge enforcement. In fact, there was an article about two major US-based D2C providers that had issues with Linux-based browsers, meaning that the content which was protected by Widevine DRM, they would not be played back on Linux-based browsers because the Widevine server was enforcing the VMP requirement. So I think it's very important for subscribers that they update their browsers and make sure all their platforms do support the latest version of VMP.
Thank you, Ali and Nicola. Check out the second article of How to Trust Your Player, which was posted last week. It covers the details of what we discussed today. Look out for additional articles and fireside chats over the course of the series. Also, don't forget that we will wrap up the series with webinars, so stay tuned for more details to come. And as always, we're also keen to hear your views on the topic, so please get in touch. Thank you.
Thank you.
Thank you.